All right, section 4.3. Yesterday we talked about ionic bonds. And remember, ionic bonds is when they were taking or giving electrons. But sometimes you can't take things and hog them all to yourself, right? Anybody who has a sibling knows you can't hog things by yourself all the time. What do you have to eventually do? Share. And that's how a covalent bond works. It's the same exact way. Who has brothers and sisters, right? I have 2 brothers and a sister. Let me tell you a story. Best Christmas present ever was 1991 Christmas present. Mom gave us a Nintendo with 2 controllers. Now that's problematic because do the math. There's me, my 2 brothers, and my sister. There's 4 of us. What do we have to do? We have to share. All right? Now, because I'm the oldest, I'm the biggest, what happens sometimes? Dang right, I beat up my brother and I got to play the Nintendo more, but eventually we always had to share. And that's the same thing that happens here. That's the same exact thing that happens with covalent bonds, is they have to learn how to share. So if we look at a covalent bond, what is the definition of a covalent bond? Electrons are not transferred, so how can they form? They are 2 atoms sharing. A covalent bond is sharing. If you had to summarize this real quick, covalent is sharing. And ionic, remember from ionic yesterday, is giving or taking. And they give or take permanently, where sharing lasts forever. So a covalent bond is when the 2 atoms kind of end up sharing. Now if this looks like a picture, H2 is a gas, right? Hydrogen only has 1 electron. So this atom is green, this atom is blue. They want to get together, they're going to end up sharing. Now how's that look from a better standpoint? Well, if we can draw a different picture of, let's see, what would be a good picture? Water. I have oxygen, and I have hydrogen. I have a hydrogen on each side. Hydrogen has 1 electron. Oxygen has 6. 1, 2, 3, 4, 5, 6. Now what's going to happen here? They are going to share so they have everything that they want. Remember, hydrogen's the exception to the rule. Hydrogen and helium are exceptions to the rule. Hydrogen and helium only want 2 electrons in their outer shell. So hydrogen's going to share this one, oxygen's going to share this one, and when they share, how many total electrons is hydrogen sharing? 2. Yay, happy. All right? Same thing with the hydrogen on the other side. Hydrogen's going to share this one, and in return, oxygen's going to share this one. And when they do that, yay, we're happy. Now that creates a bond. When you share 2 electrons, that creates a bond. So you might see these 2 are being shared, and these 2 are being shared with each other. So you may see this written as H, line, O, line, H. And a line represents a bond, or the sharing of 2 electrons. So if we look at oxygen, I know we looked at both hydrogens. So if we look at oxygen, how many total electrons does oxygen have? 1, 2, 3, 4, 5, 6, 7, 8. Oxygen has 8 in its outer shell. Yay, oxygen's happy. So that is kind of how it works. You're going to share electrons. If they share 2 electrons, it counts as 1 single bond. So kind of keep that in mind. That is a picture of how covalent bonds work. Right? Remember, every atom wants 8 in its outer shell except hydrogen and helium. And hydrogen and helium are our 2 smallest elements, and they can only fit 2 electrons in their outer shell. So kind of keep that in mind when we talk about covalent bonding. A little bit of vocab here. A molecule. A molecule is what we call a covalent compound. Yesterday I said, what's an ionic compound? It's formed by an ionic bond. A molecule is formed by a covalent bond. So just something to kind of keep in mind there. Now when we talk about molecules, atoms can be held together. All right, don't worry about that. Don't worry about writing this down. And the cool thing here is many non-metal elements exist as diatomic molecules. That means they're attached together. Like oxygen. When you breathe in oxygen, you're not breathing in O, you're bringing in O2. And what that means is O is bonded to itself. There has to be two oxygens together. Like chlorine, something you might clean your pool with, would be bonded to itself. Now, the thing about oxygen, and not to confuse you, is that actually is sharing 4 electrons, so they have 2 bonds, or what we call a double bond. And that's what we're going to jump into on the next slide here. Sometimes atoms not only share an electron with each other, they might share 2 sets of electrons, or 3 sets of electrons. So what does that look like? Well, we have a double bond. All right, when we have 2 atoms sharing 2 pairs of electrons, it's going to look like a double bond. Now, let's do carbon here. Carbon's in the middle. Carbon has 4 electrons around it. 1, 2, 3, 4. Oxygen, I'm going to do a different color here. Oxygen has 6 electrons around it. And the same on this side. 1, 2, 3, 4, 5, 6. Now to share, what's going to happen? Carbon's going to share this one and this one. And they're going to share on this side this one and this one. If you count up the total number of electrons for carbon in the middle, you get 1, 2, 3, 4, 5, 6, 7, 8. You get 8. And if you do the same for carbon or oxygen, you get 1, 2, 3, 4, 5, 6, 7, 8. You get the same exact thing. But in this example, unlike the first example where they were just sharing 1, now they're sharing 2. We have 2 pairs of sharing on each side, so this would look like this. 2 lines is a double bond. So 2 lines is a double bond. So 1 line or 1 share, 1 pair of sharing was a single bond. 2 pairs of sharing is a double bond. Any guess what you call 3 pairs of sharing? Any guessers? Any takers? That's right. 3 pairs of sharing is a triple bond. So what does a triple bond look like? All right, throw it in here. Now, to kind of redraw this so you can kind of get an idea, we have nitrogen on one side with 5 electrons. We have another nitrogen on the other side with 5 electrons. And what's going to happen? This pair is going to share, this pair is going to share, and this pair is going to share. And how many does each nitrogen have? Well, we can prove it. 1, 2, 3, 4, 5, 6, 7, 8. Each nitrogen has 8 total electrons, so they're happy. So unlike the double bond, it's going to look like this. 1, 2, 3, 3 lines, and there's N. Now the question becomes, can we have a quadruple bond, which is 4? Not really. We really just have single, double, and triple bonds when we talk about covalent bonds. So, all right, unequal sharing. Now this comes back to my story with my brother. We got this Nintendo. I'm bigger than my brother. I punch my brother. I get to play more Nintendo. What's he do? He goes, yells at mom. Mom tells me I got to share. What the heck? She tells me I got to share. That's stupid. I don't like sharing with my brothers and my sisters, right? It's dumb. It's a good person, though, so I share. Here's the hint, though. Sometimes, if you have brothers or sisters, do you guys always share equally with one another? Not necessarily, right? Same thing happens to atoms. Sometimes atoms don't like to share. Like, for example, I would hog the Nintendo controller more than my brother so I could play more. Same thing happens for atoms. Sometimes one element, in this case oxygen, is going to hog that electron more than hydrogen will. And that creates a little bit of problems. So what we call that, there's 2 types of bonds. 2 types of covalent bonds. The first one is polar covalent. Polar covalent is equal sharing. They are shared equal. Right. Polar covalent is equal sharing. Non-polar covalent. Oh shoot, I screwed that up, guys. I'm sorry. Polar is not equal. Sorry, I goofed. Non-polar is not equal. Non-polar is equal. Now, you guys all have brothers and sisters for the most part. Which one do you think exists more in the world of chemistry, just like real life? How many of you actually share equal with your brothers and sisters all the time? Right? If you do that, good job for you. Right? I'm going to guess that most of you share, but it's not equal sharing. That's just like polar bonds. Here's an example. You can see all the black dots represent how often they share. Look at how much oxygen is hogging this in comparison to hydrogen. They're still sharing, but it's not equal. And that's called polar covalent. Polar covalent is not equal sharing. Non-polar is equal sharing. Just have to clarify that. All right, don't worry about that on the bottom. Last little thing here. We're not going to worry about this slide at all. I'm going to skip it. Last little thing here. Polar molecules contain stronger attractions than nonpolar. Why? Because one person is pulling at the electron more and they don't want to let go. Just like I was pulling at that Nintendo controller way more than my brother, I was never letting go. Even though I was sharing, I was hogging that Nintendo controller. So that bond is strong. When that bond is stronger, it creates a couple things. For example, water has great surface tension. And why does it have great surface tension? Because it's a polar bond. And we'll kind of talk more about how that works in class. We'll do probably a lab explaining the difference between ionic and covalent. But in summary, covalent bonds is the sharing of electrons. Right? Just like I used to share that Nintendo controller with my brother. Except for sometimes atoms, just like me with my brothers and sisters, I don't share equally. And when I don't share equally, it's called a polar bond. And when I share equally, it's called a non-polar bond. Just a little heads up there for covalent bonding. This is GK, and I'm sounding out.